This thing has read more text than all of humanity combined, and it hasn't understood a single word. In the next few minutes, I'll show you what's really in here, what a model is, and why some are large, some are fast, some are reasoners, and some are hybrids. Hit like now. By the end, you'll tell them apart better than plenty of people who work in this field.
Let's start from the beginning. Everyone says model. The model answers. The model gets it wrong. A new model just dropped. But a model, physically, what is it?
A mathematical function. A gigantic one, but a function. Text goes in. A prediction about the next word comes out. There are no secret rooms inside, no little man reading. There are billions of numbers, called weights or parameters, that turn the input into an output. If you were hoping for something more romantic, I'm sorry. It's matrix multiplication. Lots of it.
Billions of numbers. And where do these weights come from?
At the start, they're random, and in fact, a newborn model produces garbage. Then training begins. You show it a real sentence with the last word hidden. It tries to guess it, gets it wrong, and you measure by how much. That error is used to nudge every weight by a whisper in the direction that shrinks it. It's called gradient descent, one tiny step toward less wrong, repeated trillions of times over nearly everything humanity has ever written.
So it learns by fumbling around.
Fumbling, but with an iron method. Think of Évariste Galois. At 20, he had invented mathematics his professors couldn't understand, and he failed the entrance exam twice because he skipped steps. The model is the exact opposite student. Not one spark of genius in its body, but it takes billions of microscopic steps and never skips a single one. Galois in 1 night, the model in 3 months of data center. The funny thing is that an examiner would still fail Galois and pass the model, which says more about exams than about intelligence.
Okay, it's read everything. So inside there's some kind of library, an archive.
No. And this is the most important point of the whole episode. The texts pass through, the weights remain. There is no copy of Wikipedia inside the model. What's inside is what the text left on it. Regularities, structures, the fact that after the cat climbed onto thee, you get roof far more often than theorem. It's a compression of the world. To guess the next word well, you're forced to absorb grammar, facts, styles, even a bit of naive physics. That's why it seems to know things. It has distilled them, not filed them away.
And when I ask it a question, what does it do? Does it remember?
It completes. It takes your question and generates the most likely continuation, one word at a time. Often the most likely continuation is also the correct one, because it has absorbed more text than anyone in history. But likely and true are not synonyms. And when the two diverge, the model doesn't notice. It keeps going, full of confidence. These are called hallucinations, and we'll devote a whole episode to them.
Diogenes, what are you doing?
Looking for a model that says, I don't know.
He's been searching for 2,400 years. With models, the search continues.
Now for the jungle of names. Large, mini, flash, reasoning, expert. A new one every week. How do we sort this out?
With 4 families. It's not an official taxonomy, but it covers almost everything you'll meet. 1, the large models, the frontier ones. 2, the small fast ones. 3, the reasoners. 4, the hybrids. And it's worth looking at them one by one, because the difference isn't marketing, it's engineering.
Let's start with the big ones.
The more weights you have, the more world you can compress. And weights have a technical name, parameters. When you read 120B in a model's name, that B stands for billions. 120 billion parameters. Some real numbers. Llama, Meta's open model, tops 400 billion. And ChatGPT? It's large, but OpenAI won't disclose the exact figure. Estimates run into the trillions. These are the flagships, able to juggle a Latin translation, a balance sheet, and a decent joke all at once. The price is that every single word they generate puts all those weights to work. So they're slow, expensive, and they live only in data centers. It's the big professor. He knows everything, but you don't call him to ask what time it is.
And the small ones, cheap versions of the big ones?
No, a different trade. Many are born by distillation. The big model acts as the teacher, and the small one learns to imitate its answers while keeping a fraction of the weights. It loses encyclopedic culture, but on narrow tasks, summarizing, classifying, suggesting the next word on your phone, it does just fine. In exchange, it's blazing fast, costs next to nothing, and can even run on your phone without sending your data anywhere. Which, when we get to the episode about data, you'll discover is not a small detail.
Then there are the ones that reason, But weren't we saying they just complete words?
That's still all they do. The trick is where they do it. A reasoning model, before giving you the answer, generates text for itself. It tries, spots a mistake, backtracks, tries again. And only at the end does it show you the conclusion. It's spending computed answer time, not just during training. For math, code, many-step problems, it changes everything. Giving thought time improves the thought. True for them and, breaking news, true for us too.
This is where your Galois would have something to say.
Galois is the tragic counterexample. The night before the duel that would kill him at 20, he raced to write down his mathematical testament, the one group theory grows out of, scribbling in the margin, "I have no time." A reasoning model is exactly the luxury Galois never had, time to think, bought with compute. So the rule is simple: if the problem is hard, grant it. If you just need the time of day, don't.
Last family, the hybrids. Hybrids between what?
The word covers two ideas, both beautiful. The first is an architecture called mixture of experts. Instead of one enormous block, the model is made of many specialists, and a switchboard decides, word by word, which 2 or 3 experts to switch on. The result? The culture of a giant at the per-word cost of a mid-size model because everything else is asleep. The second idea is the behavioral hybrid, models that decide on their own, question by question, whether to answer you on the fly or stop and reason. Today's flagships very often are both things at once.
And the ones that see images, hear audio?
They're called multimodal, and it's still the same next word machine, where word becomes little piece, of text, of image, of sound. Everything gets translated into tokens, and the game stays identical. Guess the next piece. That's why this series is called Understanding Machines, not Understanding Chatbots. The mechanism underneath is one and the same.
Final Barstool question, which model is the best?
Wrong question, like asking which tool is the best. The right question is, for what? Simple task, repeated 1,000,000 times, small and fast. Hard problem where mistakes are expensive, a reasoner, and you grant it time. Everyday all-rounder, a large model, which today is almost always a hybrid too. You pay the bill either way, in seconds of waiting or on the invoice. And whoever sells you the best one, full stop, is definitely selling you something. Rarely a model.
Found your honest model?
Yes, switched off.
Don't listen to him. Switched on is far more interesting. In the next episode, we get into training for real. Weights, errors, and gradient descent told the way it deserves to be told. Meanwhile, tell me in the comments which family you are. Large, fast, reasoner, or hybrid. And subscribe. Understanding machines pays off. Also because they, you, cannot understand you.